Alright, ladies and gentlemen, in this tutorial I want to illustrate how we can make helical components. So we've got several helical components. We have got a helical thread. A thread profile is helical in nature. It is actually a helical groove which revolves around the inside of a nut or the peripheral of a bolt and many other studs that are having helical components. And we also have springs, because they are having the spiral nature of the spring is actually helical in nature. So how do we make this? In other words, I want to be making this spring. This is the spring that we want to be able to make, and we are going to assume that the mean or the effective diameter of this spring is 40. In other words, the circle, if you want to, if you're viewing from the top and we get a top view of this spring, the top view will have a circular nature which has got a diameter of 40 right through, and it is constant right through. And we are going to assume that this wire, the spring wire, has got a diameter of 10 throughout. So that's the wire that has been coiled with a diameter of 10. And the next important detail that defines this helical nature will be the pitch, which is the distance between two coils, basically two coils, and it must be constant right throughout. This is the pitch, a constant pitch of 10 millimeters, which must be constant right throughout the length of the spring, which we are going to assume as 20 millimeters. So it's going to be 20 millimeters, 10 millimeter diameter wire, and we have 10 millimeter pitch again with on a 40 millimeter effective diameter spring area, cross-sectional area right there. So that's exactly what we're going to be doing. So let's put everything to the software. I'm going to be inserting a helical sweep, and I'm going to be selecting the protrusion in this case. So we have a pop-up menu manager. So we're going to be selecting the default constant through axis, right hand or left hand, it doesn't matter in this case, and then we're going to click done. These are just the attributes that we are defining right here. And now we are going to be drawing the sweeping profile. That's exactly what we are going to be selecting. So let's draw this from the front plane. We click OK, and we are going to select the sketching view. Okay, we can select the top view, and we just select the top view right there, and we are going to be directed into the sketching window. Going to be directed into the sketching window right there. So firstly, I want us to make some center lines. These center lines are very, very important because they are going to create the axis of revolution of our spring, as you're going to see later on. So I'm going to select a center line. There are two types of center lines. I'm not going to select the geometric, I'm just going to select the center line here. I'm going to be selecting it. So select the center line first, and create also the horizontal center line. That's the first thing right there. Now we are going to be creating a line defining the length of the spring, which we said it is going to be 20 millimeters. And let's modify the values here. Let's modify some values. So we said, let's select everything actually. Yes, everything selected. Let's modify the values. the length of the wire, or in other words, the length of the spring. We said in this case it is going to be 20. It is going to be 20 millimeters. Not 20 millimeters as such. It is going to be 200 millimeters basically, which is 20 centimeters. So let's put it as 200. Let's go to the next dimension, which is this distance. So this distance, this is going to be my axis of revolution. I'm going to be revolving the spring around that. And we said the circle, the effective cross-sectional area has got a diameter of 40. So that means if this defines my axis of revolution, it has to be half. This distance has to be half of 40, which is 20 basically. And this distance we can just put any, just leave it like that. As can put it as 10, no problem. It's not really much mandatory. Then I'll just click done. So these are the dimensions that define the length of the spring and also the circular nature, which is 40 in this case, which has been halved by 2, which has been halved, signifying the distance to the axis of revolution right there. If you are happy with the sweep profile, we are going to click done. We are going to enter a pitch value of 10 like we had said previously. Now we are going to be defining the section, basically the section of the wire that is coiling throughout the spring. So all these have been done, as you can see in our helical sweep window that we get here. So our wire is circular in nature. I'm going to be drawing from here. It's going to be circular in nature with a diameter of 10. So let me edit this circular nature as 10. And that's it. And then we click done. After we click done, we can have a preview of this. So this is the wire that we have created, which is 40 meter in length, 40. What is it? With a 40 millimeter diameter, effective diameter cross section, with a 200 millimeter length, 10 millimeter diameter wire, and a 10 millimeter pitch that defines this thread. If you are happy, we click OK. Right here. So that's our wire. I'm happy with it. You can play with different values for the pitch and different cross sections if you want. But I'm happy with it. In the same manner, you can also make the helical thread profile on your bolts and on your nuts. Alright. Alright, but before we finish this video, I also want to illustrate how we can make a conical spring. A conical spring. Let's assume that this conical spring will have the top effective cross section as 20 millimeters, or as 40 millimeters like in this case, and the bottom cross section will be having a 70 millimeter cross section. So it will have to increase uniformly from 40 millimeters to 70 millimeters basically, and we can also change the pitch value as we are going to see later on. So let me create a new component. Let me just create a new component so that we can be able to visualize how we can make this conical spring in the same manner. It's not going to be any difficult at all. So we'll still be selecting our helical sweep protrusion, and we are going to be selecting our constants as through the axis right-handed, no problem. And when we click done, the attributes have been defined, and we are going to be selecting the sweep profile or sketching the sweep profile. Sketching this from the front plane like we did previously. Okay, sketching view from the top. Now we are going to be making that slant line, which is going to define our sections from a 40 millimeter diameter effective top surface to a 70 millimeters bottom surface right here. Now let's modify some things here, modify some or create basically our own dimensions. So I want from this point to this point to still remain the vertical length of the spring, not this one as such, not this one. Let me cancel it, let me undo. Alright, or let me just create another one. Let me see if it will obey that. Okay, let me start afresh. Yes, that has been created perfectly. And let me also dimension these parts, these points from here to the central axis. Yes, that. And let me also create from this point to that. Yes, that. So automatically the angle that has been assigned by the software will give way to our preferred dimensions right there. We're going to click OK. Let's modify these values and check regenerate. Now let's start with this part. We say the length here is still going to be 200, not like that, 200. And then we get to this value. This is now going to be half of 70, which is 35 millimeters. And then we go from here is to remain as 20 with the axis of revolution. And then we click regenerate and okay. But we had forgotten something. Remember, we need to specify also our center lines. Let's create them as that. If you are happy, we can select done. Now let's put the value for our pitch. Let's increase it to 15. Let's see what happens. We're going to create the same circular nature for the wire. You always create it at this intersection point. It's highlighted right there. If we still have a 10 millimeter diameter wire, then we click done. Let's try to preview how this thing is going to happen. It's going to, okay, so that's it. That's our helical wire that is uniformly increasing from a 10 millimeter diameter cross section at the top to 70 millimeter cross section at the bottom. Conical in nature. Having the pitch be increased to 15, we can now see that is now a open helical spring in that manner. So basically this is how you create springs, and in the same manner you can also create helical threads or basically thread profiles. Thank you.